Hey everyone, welcome to this week's subscriber question of the week. Actually, before we go on, technically right now we're supposed to have a kind of Nick episode. If you notice before the videos, there's kind of a NIC or there's SQ for subscriber question. And usually on Tuesdays I release a NIC video, a Nick video. But this weekend has been just insane. I've been out of town for a good part of the weekend, and to edit and make those Nick videos takes about anywhere from 6 hours and more. So I just didn't have the time to make one this week, which is unfortunate because this will be the first week that I haven't released an edited video, a Nick video in, since basically the channel started. So this is a monumental, unfortunate event. But that does not mean that this is going to be the first time the channel does not release a video this week. So I'm going to be answering 2 subscriber questions this week from the poll question. If you're not familiar with how the process works, then just click the link, the description box below, and it'll explain how the process works. And with that said, let's jump into the question. The question is, would our nervous system adapt to hyperplasia? It's actually kind of an interesting, more theoretical question, because we talked last week that hyperplasia doesn't really exist in terms of occurring on a grand scale in humans, even if it does at all. And this question comes from Steve Candathil. So thanks for the question, Steve. So let's talk about it a little bit. And there is actual evidence that the nervous system, and I think that's probably pretty intuitive, that the nervous system isn't just, we're here, we're anchored to everything, we're done. That's all we're gonna do. They do actually, it does do a lot. And we know that, but in terms of muscle fibers, so if, for those of you that aren't aware, your nervous system has typically what's called a motor neuron. And that motor neuron will actually innervate or attach to, in a manner of speaking, multiple muscle fibers and of the same type of fiber. So you don't have one neuron that innervates just one fiber, you have one neuron that innervates multiple fibers. And typically it's more and bigger neurons that innervate the type 2 fibers, because those type 2 fibers tend to be at least a little bit larger. Maybe not so much in humans, but certainly in animals, they're considerably larger than the type 1, and their characteristics require a larger neuron. But that's kind of beside the point. So what exactly happens? Let's say our muscle fiber does split and becomes 2 separate muscle fibers. So then we've, as I said, hyperplasia being the growth of more muscle fibers, not the size necessarily, but the growth of more, so multiplying the actual cells. Well, our nervous system, even without that process, our nervous system can actually de-innervate and re-innervate particular muscle fibers. And this actually happens with aging, and actually throughout the entire system in general. So it'll retract its axon, and look that up if you don't know what that is. It retracts its axon and will actually re-innervate its axon as well onto that muscle fiber. And it can shift where axons go. So theoretically speaking, I would imagine that if you do have hyperplasia, the body has to adapt to that. It can't just have this splitting of fibers and then that's it. Then you have one de-innervated fiber and one innervated fiber, the original fiber. That wouldn't make any sense. That would make absolutely no sense. So I would imagine that the nervous system, that motor neuron would probably sprout another axon and move to that particular motor end plate, so that muscle fiber, that secondary muscle fiber. So that would be my thought process on if that occurs. I do know that it occurs in terms of neurons innervating different fibers and changing their innervation and things of that nature. That absolutely does occur. But again, if it happens exactly that way in hyperplasia, I'm not 100% sure, but I would imagine that mechanistically speaking, that is how it works. So hopefully that answered the question for you, Steve, and anybody else that was interested in the topic. And with that said, I hope that I have the pleasure of seeing you in the very next video. Have a good one. See you.